Welcome back. We are continuing with answering the latest senior certificate, national senior certificate, May-June exam 2024. Let's go together and then we go through the questions. Question number 2, they say block A of mass 4.1 is connected to block B of mass 2.3 kilogram by a light inextensible string passing over a frictionless pulley. Block A is at rest on a rough horizontal table. Block B hangs vertically and as shown in the diagram below. A force F of magnitude 49 Newton is applied on block A at an angle of 50 degrees to the horizontal, causing block A to accelerate to the left from rest along the table. So accelerating to the left, I think you have to underline that one because that will be, it's a hint. It will assist us in determining the direction of the friction. The coefficient of kinetic friction between the surface of the table and the block A is 0.35. Know that once given coefficient of kinetic friction, because in Newton's laws, we don't work with coefficient of kinetic friction, but we work with the friction. Therefore, you will be required to calculate friction in this case. Now the diagram is given according to this, and then the first question here, 2.1, they are saying to us, state Newton's second law of motion in weights. Remember, if you want to do it better, you can always start with, say, on the side, I know that F net equals to MA, and then A is directly proportional to F net and inversely proportional to the mass. That's the first guideline. Or you go to the momentum one, which is delta P over delta T. So these are the two hints. Normally they can guide you in defining. So definition will be now when a net force, very important, not a force but a net force, acts in this case on an object, in this case the object accelerating the direction, it accelerate the object. The object will accelerate in the direction of the net force, of the net force, and in this case, and acceleration now that is produced, acceleration is directly proportional to the force. You can just say to the force is fine, or to the net force, and inversely proportional to the mass of the object. We are in mechanics and the object is key in these sections. Fine. Or one can use momentum to say, in this case, the net force, if you are defining in terms of momentum, it will be net force acting on an object is equal to the rate of change, in this case of momentum of the object, in this case. And then the last part will be that the change will be in the direction of the net force, That is when you define in terms of momentum. Both definitions will give you 2 marks. Let's move on. We come to again now question 2.2. They say to us, draw a labeled free body diagram showing all forces acting on block A while it accelerates to the left. Remember, in this case, be mindful of the recent resolution taken by the National Examination Team to say we draw only forces here, not their components. Therefore, in all cases, remember, you can't lose marks here. We always have 1 mark in all free body diagram. That is the weight. Or you can write FG. Then because there is a surface, there will be a normal force. You write N or Fn, no problem. The force that is given in the diagram is 49. You can write F, capital letter F, or write Fa, or just write 49 Newton, is okay. And then we'll have the tension, that is, once you see the rope, you know that there will be a tension in the rope, and then the friction will be this one. In many cases, we find that people are writing equal, and no problem because we are not drawing to scale, but in essence, friction will be smaller than the tension. This is the free body diagram for 5 marks. Each force, remember, is getting 1 mark. 1, 2, 3, 1, 2, 3, 4, 5. That is the 5-mark question as per this one. We go to 2.3. 2.3, it has got 2 sub-questions. There's a 2.3.1 and 2.3.2. Calculate the magnitude of the kinetic frictional force exerted on block A. Once we were given the coefficient, we know that we will be calculating. In this case, remember, calculating kinetic friction, the formula first will be Fk equals to the coefficient multiplied by the normal. Remember, in the normal, we have got 4 aspects of the normal, just to be maybe enlighten others. Then normal can be mg, normal can be mg cos theta, and normal can be mg minus f sine theta, and then normal can be mg plus f sine theta. So remember, in this case, this one normally is when the force is just applied and it's horizontal, then that's the case on a plane. Then this one is the incline, the body is on an incline. This one is when now we are pulling, which is where we are. We are pulling here, pulling. That's where we are in this. And then this one is when we are pushing. That's the simple thing. Fine. Now you know the 4 expression of normal. So each one will be applicable to a particular. In this case, we are pulling. Therefore, will be in the number 3. Therefore, our answer will be now 0.35 multiply in brackets will be now mg. The mass of the object there is 4.1 according to the given, multiplied by 9.8 minus the force is 49, sine of 50 degrees. Then if you use your calculator, hopefully you will get somewhere around 0.93 Newton. I think that's much better. So 2.3.2. Let's go through that one. They say calculate the magnitude of the acceleration of block A by applying Newton's second law to each block separately. Very explicit. Good examiner in this case to say apply, don't use the system approach, but apply Newton's second law on each block. Therefore, you have to now tell us which block are you working with. So now I can tell the examiner that I'm working with block A now, 4,1 kilogram, or I'm working with block A. Then I'm using Newton's second law, F net equals to MA. And then according to this free body diagram, now remember I'm now allowed to can use the components. I will have the Fx and the Fy. So which means that now both tension and friction are against the Fx. Therefore, I will have now the fx, which is 49 cos 50 degrees, minus the tension minus the friction is 0.93 equals to 4.1a. And then from here I can now simplify it to say it will be 30.57 if you use your calculator, the difference between the two, and then minus t equals to 4.1a. That's my first equation. I can call it equation 1, no problem. Now let's move to the next object now, which is block B, or just say 2,3 kilogram of block B. Fine. Now I'm telling examiner to say I'm using Newton's second law. Then find yes, and then according to this one, there are only two forces. Therefore, because the object is accelerating in the direction of, there's two forces here. There's a upward force, which is your tension. The tension is upward, and then the weight is downwards. Therefore, if the object is acting in the direction of the tension, therefore the tension is bigger. Therefore, I will have tension minus the weight becomes in brackets 2,3 multiplied by 9.8, and then equals to 2,3a. Fine. Then if I simplify it, I can now say the tension equals to 2,3a plus 22.54, which is the product of this. Now I can take the tension, put it here, and then find the value of a. Yes, then this will be therefore 30.57 minus the inside of the tension. I put 2.3a plus 22.54, and then equals to 4.1a. From here now I can use my calculator. Then obviously the final answer will be 1.25 meters per second squared. That is the acceleration of the system, that which is the last question in this case. You get 5 marks for doing this. So I hope it's relatively clear when we are requested to apply Newton's second law on each block. This is what it means. So on each block, then you have to apply it in this fashion. Make sure that you show us which one are you working with. Are you working with B or you are working with A? It must be explicit there. So I'm working with B, so that the mass here, we know that it will be the mass of A. The mass here will be also the mass of B. But remember, in the free body diagram, you are allowed. Now, when you are resolving this, you can work with Newton's second law with this two-dimensional force. You now have to use the component. So you resolve this one into components. That will be a best way of dealing with this. I think it's much clearer now, Newton's second law. We'll move to the next question. Let's pause for now.